Gases, which are also fluids, are made up of tiny particles called molecules that are constantly moving due to their kinetic energy. When concealed in a container, these molecules will keep colliding with one another and also with the walls of the container. As these molecules collide with the walls of the container, they will exert a force on the walls of the container as a result of their kinetic energy. This force over an area is what is known as pressure. In other words, gas pressure. So we can see that the gas is continuously exerting pressure on the walls of the container. But what do you think would happen if we increase the volume of the gas by increasing the size of this container? This will result in fewer collisions between the molecules and also between the molecules and the walls of the container. This will also imply that fewer molecules will be hitting the walls of the container, so the force on the container will decrease while leading to a decrease in the pressure on the walls of the container. Now, what do you think would happen if we reduce the size of the container to a smaller size than the original size? Of course, the pressure will now increase. This is because the rate at which the molecules will be hitting the walls of the container will also increase. From this illustration, we can see that by increasing the volume of the gas, the pressure of the gas will decrease. Also, by decreasing the volume of the gas, the pressure of the gas increases. These observations were first experimented by Robert Boyle, who stated the relationship between the pressure and the volume of a gas. And this is what is known as Boyle's law. Boyle's law states that the pressure of a fixed mass of gas in a closed system is inversely proportional to the volume of the gas under constant temperature. This means that if the mass of the gas and the temperature do not change, then the pressure of the gas will increase if the volume is decreased, and the pressure will decrease if the volume is increased, as long as it is a closed system. This can also be written mathematically as pressure P is inversely proportional to the volume V. To remove this proportionality sign, we will insert a constant, K. If we make K the subject of the formula, then we have K is equal to PV. What this means is that for a constant mass of this gas at a constant temperature, the product of the pressure and the volume must be constant. For instance, using our earlier illustration, if the pressure of the gas was initially P1 and the volume was V1, then if we reduce the volume of the gas to V2, the pressure will increase to P2. What this law means is that if we multiply P1 and V1, the value we will get must be equal to the value we get when we multiply P2 and V2. In other words, P1 V1 is equal to P2 V2. If we try to plot a graph of pressure against volume, what we will get is a curve that is, as you can see. So let us recap what we learned in this lesson. The relationship between the pressure and the volume of a gas is described by Boyle's law, which states that the pressure of a fixed mass of gas in a closed system is inversely proportional to the volume of the gas under a constant temperature. This is also mathematically represented as pressure multiplied by volume is equal to a constant. So take care and bye for now.